Thanks for the detailed F-core explanation. Let's move ahead. Can you explain what RESTful API design principles you follow in your .NET projects and share a real-world implementation experience?
Definitely. RESTful APIs are a big part of all my .NET projects, and I always aim to follow the key REST principles for better scalability and maintainability. Let me walk you through a real example. I worked on a vehicle service management system where car owners could schedule services, track their vehicle's service history, and get part replacement details. This project heavily depended on APIs to connect mobile apps and web portals with the backend. Here's how we applied RESTful principles. First, we used clear resource-based URLs, for example, API vehicles to represent all vehicles, and API vehicles services to get a specific vehicle service history. This made it intuitive for both developers and clients to understand what each API did. Second, we followed the proper use of HTTP verbs. Get to retrieve data, post to create new entries, put for full updates, and delete to remove resources. This mapping helped maintain clarity in API behavior. Third, we ensured stateless communication. Each API call carried its own authentication token, usually a JWT, and no session data was stored on the server. Fourth, we consistently used HTTP status codes to give meaningful feedback. For instance, 200 OK when data retrieval was successful, 201 created after a successful post, 400 bad request when the input failed validation, and 404 not found if a specific vehicle ID didn't exist. Fifth, and this was really appreciated by our front-end teams, we maintained a consistent response structure across all endpoints. Every API returned a response that had 3 parts: a status code, a short message describing what happened, and the actual data, if available. So even when an API failed due to validation errors or exceptions, the response structure remained the same. This consistency made it much easier for the mobile and web teams to handle different scenarios uniformly. No surprises, no breaking changes. 6. We implemented API versioning from day 1, starting with a Python. That gave us flexibility to roll out future changes without affecting existing clients. And finally, we enforced strong input validation using attributes like required and range, and returned clear messages like service data is required, rather than vague errors. This improved user experience and reduced debugging time. So overall, REST is not just about working endpoints. It's about designing APIs that are clean, consistent, and future-proof. In every .NET project I work on, these principles are part of my core backend development approach.